Welcome to my second video on parameters. So, do you have physics homework? Because if you do, you're about to learn how to be able to do that. So, first, let's go ahead and just review what we learned. We can write methods, public, static, void, print stuff. And we can write these methods, and they're just basically little extra commands, almost miniature programs that we can write. And we do this because we hate redundancy. So I can just put whatever I want in here again, system.out.println. And when I call this method print stuff, it's going to print out whatever it's going to run this little command over here. Okay. What I can also do is, take in arguments, as we discussed in the last video. So let's go with print sum. This one's fairly straightforward. We're going to take in two integers, int x and int y, and we're going to print out their sum. Nothing too exciting here. Given an x and a y, we are going to system.out.println. So the sum is x plus y. And of course, this is not correct yet. But the first thing I want to note is notice that for those of you who know how return statements work, notice that I'm not using any return statements yet. And I'm just going to be using, I'm just printing stuff out. So we don't have to worry about returning stuff yet, if you know what that means. I'm just currently printing things out. And I have the habit of putting print or draw or say as the first word of my method or function if I don't want to return something, if I'm using a void method and I'm printing something out. So that's just a habit to use when we're doing these print line methods. So system.out.println, the sum is x plus y. Now this isn't completely correct, so let's go ahead and remember that our computers are evil genies. They will do exactly what we tell them to do. So print sum. So first off, again, I just can't call it like this, right? Print sum, if I look at the error, says it expects an integer and an integer. So we need to pass it two integers. So 5 and 10 for an easy sum of 15. If we add those together, we'd expect 15. But if we print this out, we say it says the sum is 510. Well, again, this is because the computer does exactly what we tell it to. So it says to print out, the sum is plus x. So in order of operations, we do addition left to right, and when we add a string to a number, the number gets converted into a string. So the sum is 5, and then we add the sum is 5 to 10. So the sum is 510, it says. So we have to enforce order of operations on our own. So we can do it like this. The sum is 15, so now the parentheses handled first. Or if we don't want to worry about that, we can just create a int sum variable that takes in x plus y. So x plus y gets stored in sum. And we print out the sum is sum. So we can do, as you can see, we can kind of do some nice mathematical functions on this. And what's nice about this, again, is that this is a method that we can just reuse. So let's get some practice with using these methods in for loops, since that's going to be the focus of our homework. Static void print count to int n. So this is a fairly common thing we're going to be doing as part of your homework, which is basically where you're going to be asked to print out all the numbers from one to another. So a lot of times, if you want to remember what you're doing, you should add a comment over here. Method prints all integers from 1 to n inclusive. Okay, so everybody understands what the target of this method is now. So now for int I is equal to 0, I is less than n, I plus plus. What this will enable us to do is that this will enable us to, oh, sorry, 1, because I've got a habit of starting from 0. So this will print the numbers 1 up to and including n. So 1, 2, 3, 4, 5, 6, all the way up to n. So if I pass in 10, this loop will run for that amount of times. Now I need to add for system.out.println I, and we'll just run it, but then we're going to go back to what I had previously. Oh, and if you're wondering why I'm speaking so quietly and soothingly, it's because I've got a baby upstairs who's trying to get to sleep, so we're going to try our best not to wake him up. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now, let's assume that we had what I had earlier. I is equal to 0. I is less than or equal to n. Now this is actually kind of useful because a lot of times when we start a loop, sometimes we don't want to do anything at the beginnings, as you'll see with the ASCII art that we have to draw. So here, this loop runs by starting at 0. Now, then this is what I had initially. This loop starts at 0, and it goes all the way from 0, 1, 2, 3, 4, and it goes all the way up to, but because it doesn't say less than or equal to, it just says less than, it won't include n in the count. So when I do, so this, if I run this now, it won't print the numbers 1 through 10, it will print 0 through 9. And if we make a modification over here, it's going to be 0 through 10. But we're going to stick with this right now, because we know that this will run exactly 10 times. But also be aware that this also runs exactly 10 times, from 0 up to, but not including n. All right. Let's go and write something similar. Again, say void count by 2s. Okay, so this method we are going to count by 2s rather than counting by 1. So we're going to start at 1 and we're going to count by 2s all the way to that number. So rather than I plus plus, what we do here is that we increment by 2. Plus equal 2. Count. So notice how this doesn't include 10, because when we get to 9, we plus equals 2 to get this to 11, which is not less than the number we passed in. In fact, it's greater than. So that will mean the loop won't run anymore. But we can actually, again, abstract this out so that the method's more reusable. So count by x. And now so here, if we switch this around, we can get count to 10 by 5s. So here it would just be 1 and 6, and then that would bring us to 11, so we don't include that. So let's count from 1 to 100 by 5s. So now we've got a more reusable method. All right. Now let's go ahead and work on something practical. So this is a problem I had on the homework this current homework I gave out last semester, but I've removed it. And thanks to the magic of video editing, I was able to just grab it and paste it in right here without you even being the wiser about it. So the question is, we need to write a method given as parameters, a thing that travels for time number of seconds at velocities meters per second and accelerates at acceleration. Print out how far that thing has traveled at each second from second 0 to second time. And this was a very poorly worded equation, or problem, unfortunately, which is why I removed it. So let me try to explain what I wanted to do, and I've replaced it with something much better for it. The idea here is that there's this basic equation in kinematics, which says basically the amount of displacement, the amount of time that you've traveled, is equal to velocity times time plus 1/2 the acceleration times time squared. Now, the first part of the equation makes a lot of intuitive sense, which is that basically, say if you're going for, if you're traveling 60 miles per hour and you travel for 10 hours, then you've traveled 600 miles. And this second part of the equation tells you if you're constantly accelerating by a certain amount, if you keep getting faster and faster, then how much additional ground are you going to cover? So this will take in the amount of time we travel, the velocity, and then acceleration. And I think they might have just clipped out some stuff when I copy pasted this in, but so watch for that. So let's go ahead and write this. So public static void kinematics. So this we are going to travel for time number of seconds, and we'll let time be an integer because we want to travel for this many time units, whatever that unit is. And so again, we don't paste in units here. We just have integers and then we have values. And we'll go ahead and make everything doubles. So double time, double velocity, because even though this equation uses v and a and t, we shouldn't constrain ourselves to using letters, single letter variables, because that's going to get confusing. And then double acceleration. Okay, and the idea here is that we can use these parameters to figure out how far we've traveled. Again, I apologize for how poorly worded this original question was, but I'm going to just build up on it. So let's go and say double distance is equal to this equation, which is velocity times time plus 1.0 over 2, which would, right? And we can't just do 1 over 2 like we normally would, because 1 over 2, that becomes 0. So here we're going to go 0.5 times acceleration times time. And you might be instinctively trying to do this, but that's not going to work. That's not the square operation in Java. We'll learn how to do that in a bit. So instead we're going to do velocity times time plus 0.5 acceleration times time times time. System.out.println distance. So this will tell me how much distance I've traveled. But of course, this is assignment on for loop, so we've got a bit more to do on this. So kinematics. So let's say we've traveled for 10 hours and we're going 60 miles per hour. And notice that I passed in an integer here, and we're going to accelerate by 1 mile an hour each hour. As I was saying, notice I put in an integer over here, and an integer over here. Okay? But this takes in doubles. The variables don't match, but it's still not going to give me an error. Why is that? Well, the answer is because you can store integers in doubles, right? They'll just automatically be converted to doubles. So 10 will be passed in as 10.0, 60 will be copied over here, and it's going to become 60.0, and 1's going to get copied over here as 1.0. So now let's go ahead and run this. And so it says we've traveled 650 miles. Okay? But that isn't necessarily... So now what I want to do this is that we want to print out how far the thing has traveled from each second, from second 0 to second time. So in other words, we want to print it out. We want to go second by second, or, well, if we're assuming this is seconds, time is in seconds, then we were doing it with hours. So let's translate this to hour. We want to print this out hour by hour from the beginning, where we haven't moved at all, to this amount of time. So let's go ahead and... So basically we're going to count up to time and change our equation again. So for double, so we can totally do this, double t is equal to 0, because we want to start at 0, and we want to go up to and include second time, t plus plus. And again, I'm sorry for the poorly written problem, which is why I removed it from the homework. I don't think I realized how poorly I wrote it first time around. We're going to just paste that in there. And rather than putting time in the equation over here, we'll just replace it with t. So it'll be 0 for the first bit. So the first iteration will be 0, second iteration will be 1, third iteration this will be 2. So let's see what happens now. Prints out 11 different results, and at our bottom we've got 650. Here we've got 0, then 60.5 because of that acceleration. We then have 122 miles traveled, 184.5, and so on and so forth, till at hour 10, as opposed to seconds that was originally postulated, we did 650. And this still works if we want to do seconds and just translate this to meters per second instead. All right.